Okay, in this video I'll discuss the extended part of the chapter matrix. So very important topic I'll discuss today. So the topic is transpose of a matrix and related information. Transpose of a matrix and its related many definitions are there, that part I'll discuss. Okay, so the first thing is, what is transpose of a matrix? It is very easy idea. Okay, suppose A is a matrix which is some elements I am taking 2 3 5 7 1 2. Then this is a matrix. We know the order of the matrix is what? 2 rows and 3 columns are there. So 2 cross 3 we can say. Okay. So transpose means when A is a matrix is given, A transpose is denoted by A T, or sometimes A dash also we are writing. So I'll prefer AT, this symbol. AT represent the transpose of this particular matrix. So A transpose will be when the row transform to column. 2 3 5, this is the first row. When we will write column wise 2 3 5, see first row transform to first column, by the same way second row transform to second column 7 1 2. Okay, so this become 3 cross 2 matrix. Okay, so this is the idea of transpose of the matrix. So transpose means what? When a row of matrix converted to column. Okay, so this is the idea of transpose of a matrix. Clear? So I hope the video is clear to all of you. So one more example I am taking, then it will be easier to you. Suppose B is another matrix which is 2 0 minus 3 5 1 7 3 7 2. This is one matrix. Okay, extended part of matrix. Okay, in class 10 you have done many part, but here it is interesting part it is. So B transpose will be when row transform to column, that is called transpose matrix. Okay, so first row 2 0 minus 3 we are transformed to column. 2 0 minus 3 is first row. So when we will be writing 2 0 minus 3, first row transform to first column, by the same way second row transform to second column, and third row transform to third column. Then this is the transpose of the matrix B. Understood? So transpose means the simple thing, when a row transforms to column, this is called transpose matrix. Okay, now this is the clear idea. It was there in class 10 who are belonging from ICSE board. Who are from ICSE board, they have that idea, transpose. But the thing is, now I am going to discuss about the extended part of this chapter. Means by use the definition of transpose, many more definition we will get. Okay, before that let me tell you some property of transpose. Properties of transpose. So the first property is, suppose A is a matrix we have, transpose we have taken. If we get back again transpose, then what will happen? If you just imagine, then you will get the answer. A transpose, then again transpose if we take, then we will get back the matrix A again. Because if you imagine, take one example. Suppose A is a matrix, very small example I am taking, 2 5 3 1 0 2. If we take A transpose, then row transforms to column, so 2 5 3 and 1 0 2. If we take the transpose again on this matrix, A transpose whole transpose, then what will happen? Again row transform, first row transform to first column, then 2 1, second row transform to second column, then 5 0, and this is 3 2. Class 12, sir, it is there in class 12, but you can understand it. Okay, so see, A transpose again transpose if we take, then we are getting back the matrix A again. Okay, so that is why A transpose, the whole transpose means we will get back matrix A. So this is the first property. Second property is A plus B whole transpose equals to A transpose plus B transpose. We can distribute the transpose directly. If there is minus, then minus also will work. But the problem is with the third property, that A into B whole transpose equals to, this will be B transpose into A transpose. This is the important property. Most of the students making mistake here. A into B whole transpose equals to B transpose into A transpose. It will be reverse. Understood? So this is the third property. So the simple thing, transpose, what is transpose, that I said. After that, some property, three property basically I said, but the most interesting part is on the basis of this transpose we'll get to know some definition of new type of matrix. As for example, first I'll say about symmetry matrix. Symmetric matrix. Okay, so let me consider one example. After that I'll give the definition what's of symmetry matrix. Let me explain it first by an example. Suppose one matrix I am taking A, which is 2 3 5 3 minus 1 minus 3 5 minus 3 2. This matrix I have given to you. Let's take that transpose of this matrix. After that we will check what will happen. Let's get the transpose. So A transpose equals to what? Transpose means what I said, that all the row transform to column, or you can say all the columns transform to row. So suppose we are transforming this row to column, then 2 3 5 row wise here it is, so we will write column wise, so 2 3 5. Okay, by the same way second row transform to second column, so 3 minus 1 minus 3 here row wise it was, I'll write column wise, then 3 minus 1 minus 3. By the same way third row transform to third column, so 5 minus 3 2. So I have taken transpose. Now if you observe the matrix A and this matrix, resulting matrix A transpose, then see one interesting result we have found, that A and AT, these two are same matrix. See here, whatever elements are there, 2 3 5 3 minus 1 minus 3, we have taken the transpose, then still the matrices are same. Here A and AT are same matrix, so here we have found A and AT same matrix. So if we have such matrix, then this matrix is known as symmetric matrix. Symmetric matrix. It may not happen for any other matrix, okay, but this matrix has some speciality. That is why when we are taking transpose, then we are getting back that matrix again. So such matrices are called symmetric matrix. Okay, so what should be the definition of symmetric matrix? That definitely no, in class 11 matrix is not there, in class 12. Okay, so definitely I am taking one more example, then you will get it easily. Suppose A equals to, I am taking very short example, I am taking 2 5 3 7 1 9 4 3 2. Let me change the name. Instead of A I am writing B. Okay, now if you take B transpose, then 2 5 3 row wise there, so 2 5 3 column I have written, 7 1 9 column wise, 4 3 2. Now see here B and BT, B and its transpose, these two matrices are not same, so we can say B is not a symmetric matrix. If it is symmetric matrix, then after taking its transpose it should be same, it should be invariant, it should be unchanged. Okay, so there is a speciality of the matrix, right? So that is why such matrices are known as symmetric matrix. Okay, so what should be the definition of symmetric matrix? Definitely a matrix is symmetric or not, we can check verbally. I'll give you the short trick after some time. So let me write the definition first. Symmetric matrix. So definitely symmetric or not, that I'll check when we have a square matrix. Okay, so a square matrix capital A is said to be symmetric if what? If after taking its transpose we will get back the same matrix. So AT equals to A. This would be the definition. Understood? Very good. Next is I'll discuss about skew symmetry matrix. Symmetry we have done. Next is skew symmetry matrix. I am telling you the short trick. Let me discuss the definition of symmetry and skew symmetry. After that, I'll give you the short trick how to understand the matrix is symmetry or skew symmetry. By observing the matrix, you can say within 1 or 2 seconds you will understand that matrix is symmetry or skew symmetry. Before that, let me tell you about skew symmetry matrix. Again, by one example I am discussing. Suppose one matrix I am taking A equals to 0, 5, minus 2, minus 5, 0, 3, 2, minus 3, 0. Okay, let's take the transpose of this matrix. So if we take transpose of this matrix, then again row transform to column. So first row changes to first column 0, 5, minus 2. Second row changes to the second column. Third row changes to third column. Okay, this is we have the transpose of matrix. Now if we try to relate the matrix A and A transpose, I am doing one thing. Okay, here A matrix we have. If we multiply all the elements of A matrix by minus 1, then what will happen? Minus 1 means minus A equals to, if we multiply all the elements by minus, then what will happen? 0 minus, here by minus, then it will become minus 5, it will become 2, minus means 5, 0 minus 3, minus 2, 3, 0. So see here minus A and A transpose, these two are identical matrix, means same matrix, you can see. Okay, so in this case what is happening? In case of skew symmetric matrix, A transpose will be equals to minus A. So this is the definition. So what we can say, that a square matrix is said to be skew symmetric matrix if A transpose equals to minus A. Okay, so this is the definition. The first one was A transpose equals to A, then symmetry. A transpose equals to minus A, then it is skew symmetry. Means after taking transpose, if we get back the same matrix, then that is called symmetric matrix. After taking transpose, if we get the negative of that matrix, then that is skew symmetric matrix. So now I will discuss the short trick, means how I have created this matrix. Listen. So this idea, if you know about skew symmetric matrix and symmetric matrix, this will help you to solve the JEE problem or any other competitive exam, because you will not get the much time, right? So I can say that suppose one matrix I am taking A. Now I am going to see the short trick or characteristic of symmetric matrix. Also you will get to know from this part, that 2, 5, minus 3, 5, 7, 1, minus 3, 1, 4. Okay, so the short trick is, when we will be checking the symmetric matrix, you just, this is the principal diagonal of the matrix. Okay, with respect to principal diagonal, in the both sides same elements are there. See here 5 is there, so there also 5. There is minus 3, so there is also minus 3. There is 1, so there is also 1. So with respect to principal diagonal, if in both sides same elements are there, then that is the symmetric matrix always. with respect to principal diagonal, if you see this result, then we can say this is symmetric matrix. So obviously this is symmetric matrix. You can check with the definition by taking transpose. You can check it must be a symmetric matrix. By the same way, one more example I am taking, that B equals to 4 0 3 0 9 1 3 1 7. With respect to principal diagonal, in the both sides same elements are there, so it is also symmetric matrix. One more example I am taking, C equals to, suppose, wait, I'm coming. Wait for 1 minute, I'm coming. Okay, sorry for the delay. So C is another matrix I am taking, which is 2 0 5 minus 0 4 3 4 3 0. Let's check whether this is symmetric or not. So with respect to principal diagonal, we should get the same element in both sides. Here is 0, so this side also 0. But this is the problem. There is 5, so there should be 5. Then only it will be symmetric matrix. There is 3, there is 3. It is okay. But disturbing for 5. Here should be 5. Then only it will be symmetric matrix. So I hope you understood the short trick of symmetric matrix. So on the basis of this idea, sometimes the question is coming that if A equals to 2x3 5 4 minus 2 3y 1 is a symmetric matrix, then find the value of x and y. Find the value of x and y. Such questions sometimes it is coming for in JE. Okay, so no need to check. We know if we go through the definition, that is very easy. With respect to principal diagonal, we know x equals to 5. Very good. So with respect to principal diagonal, this both sides should be same element, so x must be 5 and y must be minus 2. Yes, the correct answer is x equals to 5 and y should be minus 2. So it is very easy. Someone can go through the definition also. If you go through the definition, then it will take much time. Understood the short trick? Now I am going to discuss about the short trick of skew-symmetry matrix. Skew-symmetric matrix. Okay. So what was the definition? A transpose equals to minus A. This was the definition. If you go through the definition, then this is the definition. But I am going to share the short trick, right? So one matrix I am taking, A equals to 0 0 0 minus 5 3 5 minus 3 minus 7 7. Sorry, I have taken randomly. I am sorry for that. Okay, so what is the characteristic of skew-symmetric matrix? Or if we have a matrix, then how we will check? By observing only that whether it is symmetry or skew-symmetry or none of these two. So for skew-symmetric matrix, the first criteria is all the principal diagonal elements should be 0. This is the first criteria. Principal diagonal elements should be 0. In case of symmetric matrix, there was no such restriction about principal diagonal. Okay, but here the principal diagonal element should be 0. All elements should be 0, and with respect to principal diagonal, whatever element will be there in one side, exactly the opposite sign will be there. Here -5 is there, so opposite of -5 is +5, so it should be in this side. In case of symmetry, what was happening with respect to principal diagonal? In the both sides, same elements should be there with the same sign. But in case of skew-symmetric matrix, the first criteria is about principal diagonal. That principal diagonal element will be 0, and with respect to principal diagonal, in the both sides, the opposite sign elements will be there. Okay, so 3 is there, so opposite of 3 is -3, it is there. -7, opposite is 7, so opposite will be there. I hope you have understood the short trick of skew-symmetric matrix. Okay, let's check one more matrix. I am giving B equals to 0, 3, -4, -3, 0, 7, 4, -7, 0. Now tell me whether the matrix B is skew symmetry or not. I am giving one more matrix. C equals to 0, 4, 2, -4, 3, -1, -2, 1, 7. So what about B? B is symmetry, skew symmetry or not? So you think about B, whether it is skew symmetry. By the definition you can go, but I am asking about the short trick which I have shared. So if we check B matrix, then what was the criteria? All the principal diagonals should be 0, and with respect to principal diagonal, opposite elements should be there. So let me check. All principal element 0. With respect to principal diagonal, both side opposite elements are there. So it will be a skew symmetry matrix, obviously. Understood? By the same way, tell me what about C matrix? C is symmetry, skew symmetry. If we are going to check, if suppose we are going to check skew symmetric matrix, then C is not skew symmetric matrix. What is the reason? Because all the principal diagonal elements should be 0. So it is not satisfying. So this is not skew symmetry matrix. Okay. One more example I am taking is about D is one matrix, which is 0, -2, 3, 2, 0, -5, 4, 5, 0. Suppose we are going to check the matrix D is skew symmetry or not. So all principal elements 0, very good. But with respect to principal diagonal, in the both side opposite entries should be there. Here -2, here is 2. Okay, 3, there should be -3, but it is not there. So we can say it is not a skew symmetric matrix. Clear? Sometimes this type of question is coming in MCQ, that A equals to 0, -2, 3, x, y, z, -3, 4, 0 is skew symmetric matrix. If this is skew symmetric matrix, then find x, y and z. Find x, y and z. Sometimes this type of question is coming in JEE or in any competitive exam. If you do B.Tech, that time also you will get this chapter. Okay, so what was the criteria? Verbally you can say. I have shown you the short trick, right? So what was the criteria for skew symmetric matrix? The principal diagonal element should be 0. So we have the result y must be 0. Next, what with respect to principal diagonal, there should be opposite element. There is -2. So at the place of x there should be 2. So x equals to 2, and there is 4 on numerical value. So opposite of principal diagonal, there should be opposite value. So z equals to -4. So this complete the solution. I hope you understood it. Okay, so this is the overall scenario, that on the basis of transpose, up to transpose it was there in class 10 who are belonging from ICSE, but who are passing out from CBSE, they won't have any idea about matrices. But up to symmetric, up to transpose you have done in class 10, but on the basis of transpose we have established two definition. One is symmetric matrix, another one is skew symmetric matrix. Okay, many more information we will discuss about symmetric and skew symmetric matrix. Okay, only one thing I have discussed, what is symmetry, what is skew symmetry. Next, the next part is very interesting result. You may feel that it is little bit difficult, but no. Okay, next thing is, suppose one matrix I have given to you A, one square matrix I am giving to you, 2 4 3 1 2 4 7 1 9. Suppose I am asking that whether this is a square matrix, so this is symmetry or skew symmetry. You may have that knowledge. You may think that every matrix will be either symmetry or skew symmetry, but no, you are wrong. Okay, symmetric matrix and skew symmetric matrix, these two are some particular type of matrix, some special characteristics are there. That is why we are telling that symmetric and skew symmetric. So if you go to check symmetric and skew symmetry without taking transpose, by definition you can check, but I am discussing, I have discussed already the short trick. So by short trick, if you go to check whether this matrix is symmetric or skew symmetric, then see this is neither symmetric nor skew symmetric. Okay, this is neither symmetric nor skew symmetric matrix. Okay, okay, next some result I'll discuss. It is very interesting result. Suppose A is any matrix. I have given you A is any matrix. We don't know about A, whether it is symmetric or skew symmetric. It is not mandatory that A has to be symmetric or skew symmetric. A is any square matrix. Any square matrix. Then the first result, which is very important, that A plus A transpose is always symmetry, always symmetric. And the second result is A minus A transpose is always skew symmetry. I'll prove it. Okay, this is skew symmetric. Okay, now the question is, here it is given that if A is any matrix it can be any square matrix, then when we will be adding A and A transpose, then we will get one matrix, and the matrix which we will get, that must be a symmetric matrix. Okay, as for example I can say for this one only, okay, that A is a matrix, this is neither symmetry nor skew symmetry. But if you take transpose, then A transpose will be what? Row will be transformed to column. I am doing very fast. 2 4 3, first row first column, second row transform to second column, then 1 2 4, third row transform to third column, 7 1 9. So what they are telling, that A plus A transpose will be always symmetry. Let's add these two matrix. A plus A transpose means you know that this matrix and this add, then what to do? Corresponding element will be added, right? 2 plus 2 4, 4 plus 1 5, 7 plus 3 10, 4 plus 1 5, 2 plus 2 4, 4 plus 1 5, 7 plus 3 10, 1 plus 4 5, 9 plus 9 18. So you see, A plus A transpose, the matrix which we have now, that is symmetric matrix, obviously. See, with respect to principal diagonal, same elements are there. By the same way, if you do A minus A transpose, then the matrix which you will get, that will be skew symmetric matrix. So this is the example, it cannot be proved. It has verified, actually we have verified it, but mathematically we will prove it now. Okay, so proof I am showing you. So to do the proof of the first one, you just see that what was the definition of symmetric matrix. If A equals to A transpose or A transpose equals to A, whatever, means after taking transpose, if we get back that matrix again, then such matrix is known as symmetric matrix. And after taking transpose, if we get back the negative of that matrix, then that is called skew symmetric matrix. So we'll prove it by using these properties. Here I have discussed some property, so by using this property we'll prove it. Okay, now we are going to prove A plus A transpose is symmetric matrix. So how to prove? So suppose A plus A transpose itself a matrix, we are going to show that this is symmetric or skew symmetric, that part. So what if we take this is a single matrix, then after taking transpose, if we get back this matrix again, then we can say it is symmetric. Okay, we are taking the transpose of this matrix where I have underlined. If we get back this matrix again, then we will say it is symmetric matrix. Okay, A plus A transpose whole transpose. So just I have discussed here the property A plus B whole transpose equals to this transpose can be given to A and B as well. So here also we'll use the property, this transpose can be given to this and this as well. So it will be A transpose plus A transpose whole transpose. So equals to A transpose keep unchanged, and A transpose then again transpose means what? A transpose against transpose means A. So see, A plus AT whole transpose equals to, we have get back, we have the matrix A plus A transpose itself. So A plus A transpose, the whole transpose when we are doing, we are getting back the matrix same. A plus A transpose only we are getting back. So what we can say? Therefore, A plus A transpose is symmetric matrix. Okay. By the same way, you can do the proof of the second one also, that A minus A transpose whole transpose we are taking, then the transpose will be distributed, then A transpose minus A transpose whole transpose equals to A transpose minus A. Now take common minus, then it will be A minus A transpose. So what is happening? A minus A transpose whole transpose equals to, we have get back A minus AT. So what? A matrix, its transpose equals to minus of that matrix we are getting back. So we can say A minus A transpose is skew symmetric matrix. Skew symmetric matrix. Okay. So this is one more result we have established, that if A is any square matrix, then A plus A transpose will be a symmetric matrix and A minus A transpose will be skew symmetric matrix. So by use of this result, and I am going to discuss one very important result which is very important for your board exam, or in joint also sometimes this questions is coming. This type of, the result is, if I am giving you any square matrix, so this is one theorem is there, theorem means which is universal truth, that any square matrix can be expressed as, try to understand, any square matrix can be expressed as sum of a symmetric matrix. It is very easy part, okay, not difficult. First time you are doing, that is why. A symmetric matrix and a skew symmetric matrix. This result, when I'll solve one example, that time you'll understand it easily. But the theorem is, any square matrix can be expressed as sum of a symmetric matrix and a skew symmetric matrix. This is the result. Okay, means I am showing you the proof, then after that one example when I'll be taking, that time you'll get it. So what is the proof or solution or proof, whatever? Listen, I am taking any square matrix A. Okay, any square matrix, you don't know about A, there should not be any special features of for A, that A should be symmetric or skew symmetric, not like that. A can be any square matrix. So what we can do, A can be written as okay, I am writing first 2A. Okay, let A is any square matrix. Okay, then what we can say, 2A means what? 2A means 2 times of A, means A plus A. After that we will write A plus AT plus A minus AT. Can I write it? AT extra I have taken, I have subtracted here. Okay, okay, so if we make the group A plus AT plus, if we make the group A minus AT, this, now these two will take to that side. So 2A equals to, it was actually 2A equals to this. So implies that A equals to, if we take to this side, then half of A plus AT plus half of A minus AT. Okay, so see, just we have proved that if we have A is any square matrix, then what about A plus AT? A plus AT always a symmetric matrix, and A minus AT is skew symmetric matrix. Okay, so a matrix, A square matrix was given, that square matrix can be expressed as sum of, this is one matrix which is symmetric matrix plus one skew symmetric matrix. So any square matrix can be expressed as the sum of a symmetric matrix and a skew symmetric matrix. So we have proved the theorem. So on the basis of this result, sometimes one question is coming. So to solve that problem, we have to memorize this line, that A equals to half of A plus AT plus half of A minus AT. Okay, so I am solving one example. Express A equals to 2, 3, 4, 1 minus 2, 3, 3, 1, 6 as a sum of a symmetric matrix and a skew symmetric matrix. Okay, so solution I am doing. So you know that what? Just I have discussed that A equals to half of A plus AT plus half of A minus AT. We can write where the first one is symmetric, this one is symmetry, and this one is skew symmetry. Now put the value, half of A plus AT. A plus AT means what? A matrix means this one, 2, 1, 3. Okay, I am doing, okay, where half of A plus AT is symmetric and half of A minus AT is skew symmetry. Okay, so given, let's calculate half of A plus AT and half of A minus AT we have to calculate. So given A equals to 2, 1, 3, 3 minus 2, 1, 4, 3, 6, then AT will be transpose of this matrix 2, 3, 4, first row transform to first column, 1 minus 2, 3 and 3, 1, 6. Let's calculate a plus 80 because we need na. So half of a plus 80 will be, directly I am doing half of a plus 80 equals to half of a plus 80, directly I am doing a plus 80. If we add these two matrix, then 2 plus 2 4, 3 plus 1 4, 4 plus 3 7, 1 plus 3 4, minus 2 plus minus 2 means minus 4, 3 plus 1 4, 3 plus 4 7, 1 plus 3 4, 6 plus 6 12. So this is the symmetric matrix. Okay, here we can divide by 2 if all the entries can divide by 2, but here 7 cannot be divided by 2, so keep half outside of the matrix. By the same way, half of a minus 80, half of a minus 80 equals to what? Half of a minus 80, this matrix minus this matrix. So when we will be subtracting, 2 minus 2 0, 3 minus 1 means 2, 4 minus 3 means 1, 1 minus 3 means minus 2, minus 2 plus of minus 2 means 0, minus 3 minus 2 means 2, 3 minus 1 means 2, 3 minus 4 means minus 1, there will be minus 2, there will be 0. So clearly see, by the short trick also you can check this is symmetric matrix, this is skew-symmetric matrix. Okay, hence A matrix means 2 1 3, 3 minus 2 1, 4 3 6. This matrix can be expressed as sum of a symmetric matrix, means this matrix plus this matrix. Half of 4 4 7, 4 minus 4 4, 7 4 12. This is symmetric part plus half of symmetric part is this one, 0 2 1, minus 2 0 2, minus 1 minus 2 0. So any square matrix I have expressed as a sum of, this is symmetric, this is skew symmetric. Understood? Okay. By the same way, some more results you can prove at your home if you really interested, that if A and B are any two square matrix, then check whether ABT plus BAT is symmetric or skew symmetric. Symmetric or skew symmetric, that you have to check. Okay, so how to check? Simple, same. A and B any two matrix. This matrix we have to check about this matrix whether it is symmetric or skew symmetric. Then how to take transpose and check accordingly? So ABT plus BAT, this is the matrix, we are taking the transpose. So what was the rule? This transpose can be distributed over this and this. So this can be written as ABT whole transpose plus BAT whole transpose. Now in case of product it will be reverse. One property I have given, see, I said very important it is A into B whole transpose equals to B transpose into A transpose, it will be second one after that first one. So here also product is there, so second one will put transpose, after that the first one BT whole transpose into A transpose, it will be by the same way second one it will be A transpose whole transpose into B transpose. Now BT again transpose, then it will get back B, so B into AT plus A transpose again transpose, so A into BT. So what we are getting? ABT plus BAT only we are getting back, na? ABT we have written this one first plus BAT. So see, when we are taking the transpose of this particular matrix, we are getting back that one. So what we can say? Therefore ABT plus BAT is symmetric matrix. Symmetric matrix. By the same way, if there is minus, then it will be we cannot conclude any conclusion. Okay, so this is one more interesting result about this. So today I have discussed about matrix transpose. After that, on the basis of transpose, whatever information Few information I have said, but many more things we can discuss more. Okay, one more idea is there, which is orthogonal matrix. This is the last topic. Next day I'll discuss more that orthogonal matrix. Here in short I am giving the definition. Suppose A is a square matrix. A is a square matrix. If A transpose and the matrix A, when we will be multiplying, after multiplying, then if we get back the identity matrix, then this is called orthogonal matrix. About this I'll make one more video, but today's class is up to this. In my next video you will get more advanced part about matrix theory, and I hope it will be interesting. And if you like the video, then definitely you subscribe the channel and must share with your friends.